can one do research as an individual? Ankur?
Yeah, whatever I said in the last answer, like it was in context of doing individual, and definitely if you're doing some project like as Vaibhav said, like if you don't have any option or any experience or any idea, then definitely if you want to do research, then you can approach the professor and whichever problem the professor is working on, then definitely you can work on that. So most of the time, like doing individual is like yes, of course you can do, and from my experience, like most of time, like when you do like individual, it means when you are in kind of university, there's no professor. Like best option is always to work with some professors. So suppose for me there was no option, like I was in engineering and physics department in NIT Surat is still, yeah, it's good. I think some from NIT Surat physics department, but yeah, it's good, but not really that good that you can approach any topic professor and you can work on. So I had no option of choosing professor, so I chosen to do the individual work. So you can always do the individual by forming a small group or like the process I suggested in the last question, and then maybe a winter time or summer vacation, you have enough time to approach any professor or like for internship. Then by your past self-learning or individual research project, so you can prove yourself to them, like to get into good research project during summertime or winter time. So this is how I think it will help.
Would you like to speak something about it? Yeah.
Sorry, should I? Yeah. I just add that, if you are, if you don't have access to any professors, and, that can easily happen, and you don't have anyone to sort of take guidance from, I think at least at sort of the undergrad level where you're just trying to get into physics, I think it's too much pressure. Like, don't think of doing novel research. If you do it, that's great. But I don't think you have to. As in, when somebody's admitting for a PhD, right? If a professor wants to take you on as his or her PhD student, they're not necessarily looking for papers from you. What they're looking for is, like I said, that solid building ground and just some skills, right? So if you just develop skills like, for example, if you have some good computational skills, you can say, I can code in Python, I can code in Mathematica. Even if you don't need a novel research result at all, right? With those skills, you can just go into a research project and do well. And that, whether you're doing it in a PhD or MSc or just a project, and you don't need any prior, like, individual new result or new paper. So certainly, I guess that's not, if you don't have an option, yeah, you can just focus on developing skills, and I think it's going to be probably as useful as anything else.
Yeah, exactly. Yeah, sometimes like doing research means not exactly producing novel work. Like maybe like as Rabia said, and even I realized that like even you can work on some problem and learn some new skills and then reproduce some result. Then this is how you can also attend a few conference and few like nearby the seminars. So you will get the opportunity to attend the conference, and without any poster, any paper, if you attend any conference, feels really bad. So you can also present and learn some communication skills, interact with the professors and scientists, and this is how I think the overall development of an individual takes place. So not exactly the research, like not being so pressurized condition, just feel it and experience the like journey, like attending conference, having interaction with professor scientists, trying to understand the research papers, how they write, and etc. This is how the undergrad level is.
Yeah, sorry for interrupting. There's a nice question by PV Plazen. Is that when we talk about independent research problems, how is it that we can recognize an open problem? How do we filter out something from the millions of papers Bhavya, you were explaining finding pockets and caveats. Could you elaborate a little more? So that'd be great if someone could answer that.
Sure, Dushyant. So basically, what I meant there was that first of all, always remember that the standard presentation of any subject which you are learning is not the complete story of the field. Okay, it's really a very smooth and very idealistic picture of what all is there to cover out the aspects of the field. Okay, and as I said, there are examples in even in classical mechanics that there are open problems. So how do you find these caveats is really just by googling. So if, for example, if you are learning a new topic, just google about it, read about it on Wikipedia. And Wikipedia, like I have realized this, that Wikipedia at the end throws a lot of non-standard knowledge which are not usually is present in standard textbooks. Okay, so while reading Wikipedia or some resources like that, you tend to realize that there are some things which you have not really learned about that topic. Okay, and that topic is not confined just to that particular textbooks. Okay, this you can also do by learning a lot of textbooks on the same topic. Okay, and different textbooks can give you different viewpoints. But the problem with this is that there are sometimes it occurs that in standard representation that particular topic is missing altogether. For example, this topic of constraint systems, again and again I am telling it because this particular topic is so important that you can imagine any Lagrangian you write and it will be a constraint system. Okay, if that is not a very trivial system, it will be a constraint system. But the topic and the formalism of constraint system is totally missing from the curriculum, the standard textbooks on quantum mechanics or quantum field theory. It's altogether missing from the complete standard discussion of the physics. So you won't find any lectures on the topic, you won't find many books on the topic, and so on. So in that case, how do you really go about learning these hidden topics which are very important in making the foundations of your physics and are also related to research? It's just by Wikipedia, as I said, was very unnecessary information at you at the end of the article. And somewhere in these articles, somewhere in these discussions, you will find these kind of pockets which will lead you to these kind of fields. And mostly these fields in physics are related to some kind of non-trivial application of some strange, funky mathematics or some strange principle which the standard representation is missing, and so on. And learning about them is also a kind of research in itself. So at an undergrad, you can call it research. You don't have to, as Weber and Ankul said, you don't have to work on something very original and novel. Finding these kind of pockets gives you the same kind of pleasure as you would be working on some original research. Because these are non-standard topics. And I think that's how you can go about it. Just search about these kind of problems on physics and different sources just to learn about them. And I think that can basically give you an intuition about how you can find these pockets and caveats in the standard representation.
In addition to that, like Googling and Wikipedia is always helpful. Like if you have any topic in your mind, suppose I say correlations in a noisy environment in any quantum system. So you just put this sentence in any journal website, like they suppose Nature or Physical Review, the most famous physics research journal. So there is search option there, and just put this sentence, and they will suggest you most. They will sort you for most recent research papers and relevant research papers published in their journals. So you can just figure out, like going through maybe 50 or 60 recent research papers, or most relevant to your sentence or most relevant to your topic research papers, and then this is how you just read the abstract, not like download every research paper. By just reading the abstract, you will get to know about their research work and what exactly the results they produce. So this is how I think you can figure out if your question or if your topic is new, or like how much work has been done in your topic, kind of. So maybe by referring 2-3 journals, such googling and Wikipedia, and searching out in some journal websites. So this is how I think it will help more.
Divyanshu, I also want to add one thing. So this is one tip which I often give to people, is that try to learn how to learn from books. So try to learn how to read books. And reading books is, like, for example, is a very so it seems very naive that we all are learning from books, and what is there to learn in learning from books. But what I meant by this is that quickly reading a book and getting a big picture of the topic which you are reading. And by this I mean that you should be able to, after learning, after reading enough books, you should be able to complete around 300-400 pages of book in, let's say, 10 or 15 days. That kind of bandwidth I'm talking about. And this you can achieve by really practicing how to get a big physical picture of what all topics are there by smoothing out details from the present. So most of the time details are mathematics, right? And it's really something which you can really smoothen out, and just try to see what all axioms or what all important things which went into building that formalism, into building that theory. And if you once you get this kind of habit of learning book, then you can really complete books of around 500 pages in 15 days, 1 month period, and that really fastens your process of learning physics. And I think that's very important when you are doing research as an individual. But if you are doing as with a professor, obviously professor will be showing you the path, but as an individual, learning from books is a very necessary skill which really you should practice, I think.
Wow. I mean, it really takes some metal to complete a book in 10 or 15 days, I guess. Yeah, it's a difficult skill to learn.
And yeah, like if you're referring to some books, don't refer some like exam or competition preparing books, like for preparing GATE or NET, like likewise those books. Prefer some standard books, and then only you can learn.
Yeah, one tip here is that try to refer to German books. So German authors tend to follow this kind of approach. So always first try to find some German author which is explaining that topic. So he or she will surely be explaining the topic by giving you a big picture and not indulging in much of details.
Something new, I guess. I didn't knew that. Yeah, anyways, let's get on to the meeting, and let's get on to the next question. What is a thesis or paper? Oh, anyone want to, Uncle? Do you want to start off?
Maybe Bebo can start with thesis.
Okay, yeah. Rabo?
Yeah, sure. Yeah, it's what you say. It's a record of your work, right? Thesis or a paper, it's what you did. And I guess, it tends to be, you set up some background, you say, you always have to set up a context for what you did, right? Or as in the sense that you have to connect it to what questions others are interested in, or what are some of the questions that, the community wants answers to, or what is something that, maybe an experiment is interested in. Set up that kind of context. And yeah, and a thesis, I think you would just, at least in an MSc thesis, there's not that much pressure. Often you don't have to have a novel result. So you just, present, okay, what all did I learn? What all did I use? And you just sort of present your results. In a paper, of course, there's more of a set template in the sense that you set up the context. You do give your result, which has to be something new. And you claim that, okay, this is the new thing we have found. And then typically there's, after that summary, there comes your, what you actually did, or sort of where you argue that what you have done is, and what you claim is the right thing. So you argue using either equations or plots or your experimental data. And then you just conclude, and usually, again, there in a paper there is some summary and outlook where, okay, we solved this problem, but of course we haven't solved these 10 other problems that this problem spawns. And then you sort of give that outlook, it's a great research problem and somebody probably work on it. But yeah, it tends to be just, you argue about the correctness of your work. It's basically that.
Yeah, exactly. Like if you do any project or doing any research problem, then definitely you wanna share with others. Like suppose if you are sending PhD application, then you can't just write this was the problem and I worked this. And if professors suddenly ask you like what was the result and can you send some work on that problem, so definitely if you join any intern, being undergrad, you also work on intern. Even professor don't ask you to submit any report, then definitely you should work on report from initial days. Like you should also summarize for yourself, not to just get certificates. So just maybe after completing your bachelor, maybe you are applying for MSc or PhD, then you can send that report. Like so, this is how it helps. And as the technical terms already explained by the.
Okay. How to compile a research paper, or what should be included? I mean, what is the general structure of a paper or thesis? Uncle, do you want to
Yeah.
talk about?
If I go for research paper, generally we start with writing abstract, and abstract is all about like if someone is reading or like your title, then if they got interest in your work, and then they will refer your abstract. So abstract thing should conclude about your like the main feeling, like what the work is exactly about. So abstract, and maybe after that you write the introduction, and introduction means like the background you read of like basic methodology and the basic concept you use, and then the techniques you use later on, like by discussing your results and like way you did, which are the like maybe the mathematics you used, and which are the computational techniques you used, or which are the improvement you did. Like this is how you develop the research paper and discuss about your results, and then finally you conclude that. So basically it's all about like long research project, and you're putting whole work in a maybe 7 to 8 paper draft. So like it should be more precise, and like should be in a proper manner. Like and during writing research papers, you also refer past researchers' work, and this is how you like you refer as a literature survey. And yeah, there is also a section for literature survey. Like you support your results from like by comparing the previous researcher results, and you also validate your research basically. So, and by referring previous researchers, you also say that, yeah, this is how I did, and this was the novel and like originality of my work is like this. So, yeah, this is how we summarize research paper. And thesis, I think, yeah, similar in a long text. Yeah, maybe back up in it. Thank you.
Yeah, that's the thesis part.
I'll just add that, the way you read a research paper, which is, as Uncle mentioned, abstract, introduction, or results, discussion, summary, references, that's the way you read it. That's not necessarily the way you write it, in the sense that whenever I've written papers, you start with the problem, you have a little idea of, okay, what's the context and, why this problem is important, but you then start solving the problem. And I think, at least in my experience, when you do a project, I think it's towards the end that I actually understand what's the broad context of this result, or sort of what are the big questions, or what are other people thinking about, and where does this result fit. And I think that doesn't necessarily come to you before starting to write. That can come after you write. And I think at the end, I'm pretty sure that at the end, the thing I'm editing, that's the last thing I'm editing, is usually the summary and the abstracts. I often write the abstract in the end, and it's funny, but you can write it in the beginning, but I think by the end you realize, either it's crap or, you know more things now than you did when you probably wrote a first draft. So yeah, it's usually not a linear process. And so, yeah, and I guess another thing, citing other people's work, that's really important. And again, to set the context of what your work does. And one example is, I think I recently submitted a paper and I did miss a citation, in the sense that there was some prior work that I missed that I didn't realize. And the referee was quick to point out that, somebody did this calculation, you should refer to them. That's what I did. But yeah, that's really important. That's the lesson.
I think there's one book I really enjoyed reading that. There's a lot of practical things mentioned. I'm just sharing the name of that book.
PhD is not enough. A guide to survival in science.
Yeah, there are a lot of things you can learn from this book. But not exactly stick to. Like, everything is not the proper or 100% right. You need to learn a few dots, like learn some random dots from different resources, and by your ideology and by your thinking process, you assemble those in a proper manner. Do the best. Sounds feasible? Yeah, this is true.
On to the next question. What are the necessary approaches or level of knowledge or degree or something else that is required to write one? I mean, writing one a research paper or thesis. So I guess, what I want to know is that how one can do research in bachelor's or in MSc, or does the coursework is proper enough to help us starting a particular research, and what happens and how do we undertake a research project during the gap years between BTech and MSc? So, Uncle, Bhavya, anyone, would you like to get on to that?
Yeah, the first I will add to the last question. The gap year must be done at some university or some institution. Then, as a research assistant post, you can always join any professors. So I think that way you will learn more things. And the necessity approach, I think, sometimes bachelor level math somehow is quite enough to understand if you're following at least four math course in your engineering or bachelor, I don't know. So that is sometime enough. And yeah, for physics, if you are following some standard book, sometimes it's enough, sometimes it's not. Then the literature survey part is also helpful for knowing, there are a few literature review papers. So they summarize, sometimes review papers are long enough and sometimes they are short. For any good or any books, suppose in quantum information, there is famous book by, I don't know the professor name, but nowadays the books are coming in form of collection of research paper, collection of work. So by referring some review papers, good review papers, you also learn the basics. Sometimes review papers also include the basics, and sometimes they develop the idea from initial to till now. So by referring standard books, by referring review papers, and yeah, so this is how you can build the necessary background. And always in parallel to that, you can just look into the problem, whichever it is. If you have developed by your own individual or by even some professors, so keep you focus on that problem statement and try to build a kind of circle or build a kind of sphere around that problem statement. Yeah.
Thanks, Uncle. Bhavya, would you like to add on to something?
No, I think Uncle had more or less covered everything. Review papers are obviously the most important aspect in this thing.
Okay, thanks. So, shall I move on to the
Even
next question? Yeah.
one more thing, like right now I'm following coursework and doing MS. So sometimes professors don't only refer the books, they also suggest some reference papers or review papers, and they say they also ask some problem in your examination from those papers only. And the best part is about here I experience about the exam pattern. In India, you say like the question will be from your book or whatever teacher is teaching, but here I realize it's totally random. Like they'll teach something basics and concept, and they'll ask you from recent research publication, like referring some research papers, and then they'll say to solve this statement or explain this statement or develop this by using your basics concept. So they used to refer some review papers also along with the standard books. So this is, I think, we should follow in undergrad also, like to learn new things.
So, let's move on to the next question. When reading a paper to write a thesis, is it necessary to understand and know the reach of each and every equation? What if one hasn't reached that level of solving such equations or doesn't know that much mathematics? So suppose what if I'm reading a paper or something, doing a project, and I don't understand it mathematics? Or what should we keep in mind when reading a research paper when we don't understand its higher level mathematics? So again, any one of you can proceed. I mean, answering that. Prabha, Bhavya, or Uncle, any one of you can do that.
I can take a shot. Well, it depends in the sense that what you are trying to do. If you're reading a paper and it is their technique of solving the problem that you have to use, then yeah, you would have to understand every equation by some means. Either you can take help from professors, your fellow students, or someone, or you can even contact the authors. Actually, that's also not a thing that's unheard of, and in fact, many people do. And again, it depends. For example, if it's not their method that you want to reproduce, but you want to sort of jump off from that. For example, if you're doing experimental physics and it's a theoretical paper and they're getting an interesting result and you want to do the experiment, you don't have to get the derivation. A good paper, apart from the math, will tell you what the math means, or sort of they would summarize that what it means, what's the final result, what's the big picture that they got. And I think if you get the big picture and it's the big picture that you have to use, then you don't have to understand every equation. Or sometimes you want to solve a similar problem but with some other technique. Again, that's an example where getting the big picture is probably enough and you don't have to understand each equation. So it highly depends on what you want to do. But it's certainly, you don't have to understand every paper you read. At least I don't.
Yeah, exactly. Like the different case when you just want to read research papers, maybe if you are in second year or third year, then first year, if you want to read research paper, then you don't have to understand anything. Just enjoy the abstract or introduction thing. You don't understand, it's okay. Even you understand 10%, 20%, it's okay. Like I was in second year and I was like trying to say like weekly I will read 1 or 2 research papers. It was my routine time. I fixed that. Like I was not understanding anything, but yeah, it was not demotivating me. I knew like I'm not at that level, so definitely I will not understand anything. So at least 10% or 20% if you're getting, then you're just enjoying things like new things, how they phrase question or how they phrase the answer. Like